Hi everybody, we're going to be talking about scientific method and going through an experiment to see how we can go through all the different steps. So first in the scientific method we want to propose a question, and we're going to look at how liquid can affect the sound in a bottle. So we want to come up with a problem that can be solved. I think that perhaps as I change the volume of the liquid that the pitch should change as it goes through, and I can check that. Here's my empty bottle. Here's one that's got 100 milliliters, 200, 300, 300, and 400. So when we're looking at that, we can kind of already see that that does actually happen. We know that pitch in this case is going to be affected by the volume of the liquid in here. So that hypothesis of that if then because statement is basically if I add different amounts of liquid, then my pitch should change because the volume of air that the sound has to resonate in changes. That's not a bad hypothesis. So then I have to design the experiment. So what I did was I looked at my bottles and I wanted to change the amount of water. That was the variable I was choosing to manipulate, or the independent variable. But there's something wrong with this experiment. And if you think about it, it has to do with what we control. In this case, I'm always using the same liquid, which is water, right? We don't want to put honey in one or, isopropyl alcohol in another one, or water. We want the same resonance to happen because it's the same liquid. So we want to control as much as we can. So if you look at this lineup of bottles, here's my control. This is what I'm going to compare it to because this is the empty one. What is wrong with this experiment? Okay, if you've had a chance to look at this, what is wrong with it? Well, I have different amounts of water. True, it's all water. But this is not okay. If you notice, if you look really closely at this, this is a different shaped container than my other 5. And that's not okay to have 2 changed variables, 2 manipulated variables, 2 independent variables in one experiment, because then I'm actually testing 2 different things. If I took this one, which is 300, and compared it to this one, which is 300, now what I'm changing is the tone for the beaker, but my water's staying the same. And there is definitely a different sound because the chambers do have a different effect. That's a different experiment. That's not the one I want to do. So right now, I'm going to take this and set this aside. Okay, so now let's go back to this experiment, where now we're looking at all the same size containers, the same shape containers. And I need to figure out the fact that I need to control some things. Like, can I test one here? Do you get the same sound as when I did here? No. So I need to know that I'm controlling many different variables, as many as I can, because I only want to manipulate the volume. I don't want to manipulate anything else. So what are my controls? Well, I'm comparing everything to this empty bottle. I've changed the liquid. What am I keeping the same? I'm using the same striking stick, in this case a glass stirring rod, for all of them. I am keeping the shape of the containers the same. Those are all controls. How hard I strike them, I'm keeping the same. Where I strike them is the same on each bottle, because if I strike up here, it could be different than down here. And you can hear the difference on the same bottle. So where I strike, how hard I strike, all of those things are things that I can control and keep the same. So one variable I want to change is the independent variable, and that's otherwise known as the manipulated variable. It's the one we change. It's the one we manipulate, called the independent variables. And only one variable at a time can be tested. That's huge. In this case, it's the volume of water. So I would expect that my pitch should change. Now, is my pitch going to go up, or is my pitch going to go down as my volume of water increases? So let's check. What happened to the pitch? Well, if you said the pitch got deeper, you're right. As the volume of water increases, there's less area for that to resonate, and you get a deeper sounding pitch. So we know that what changed is the pitch of the tone. And that is what the dependent variable is. The independent variable is the one we change. The dependent variable is the one we keep the same. And that's also known as the responding variable. The responding variable responds to the manipulation that occurred. In this case, we manipulated the amount of water. What responded was the tone. It got deeper. So I changed the pitch. That's the dependent variable. The independent variable, again, is what we changed. The dependent variable is what changes because of what we changed. So the manipulate is what we manipulate, what we change. The responding variable, the dependent variable is what responds to that change. So obviously those are probably going to be two pretty good points of data. Now, qualitative data versus quantitative data. Qualitative data is I hear a change in pitch. It sounds as if it's getting deeper. Quantitative data would be if I took a sound meter and I struck and I took multiple readings, and I can actually see the change in tone in data. That's different. Qualitative and quantitative. Quantitative is numbers, qualitative is an observation. That's kind of the easiest way to think about it. So as we change the water, the tone changed. So this is repeatable. The cool thing about this experiment is this has been known since the 1500s. This is not groundbreaking scientific change breakthrough. People play music with this. In fact, if I took these two and I was really good and I tried and I got it to work once and I couldn't get it to work again because apparently I'm not too old, but maybe I am. I don't know. You can do the same thing with, have you ever seen people who go through and they change, get their finger wet and they go through and you can actually have them rubbing the glasses and you get a harmonic sound, a resonance. And I'd show it if I could, but I couldn't get to work, so I'm not even gonna try. But this is the same container. And with different amounts of water, you can get a pitch change. So I thought, okay, that's a pretty cool experiment. But what about, is it repeatable? So what we like in science, to have a really valid scientific theory, it has to be, somebody else needs to take this data and repeat it and get the same exact thing. Well, the cool thing is if you had the same 5 of the same exact type of glasses at home and you filled them up with different amounts of water, you too would start to see that same change in pitch. Or I can literally take the same thing and change my glassware to something else. And I would be willing to hypothesize that even though I've changed the container, because I'm only changing the amount of water, my independent variable, the one I'm manipulating, again, is the water amount. My control is the same, how I strike it's the same. I should, in fact, with this container, still get a change in harmonics that gets to a lower frequency with the more water I get to. So here. And it does, it works. Even with wine glasses, this works. And you're lucky I'm doing this at my cabin because, well, and the interesting thing is I don't drink, so I use them for water. So they're actually holding what I normally do. But I wouldn't bring these in. But it does make a nice sound. So that's a repeatable experiment. I repeated the same experiment in a different container, again, only manipulating the independent variable, which was the amount of water. And my product, my result, was the same in both cases. As the water level increased, my pitch went down. Now, the cool thing about science is, if this hadn't worked at all, I would have had to change my theory. I would have had to go on back to the drawing board to figure out how to change that. And that's what science really is. If I'm disproven, it's disproven. That's the way it goes. So if I go through, I could actually design one more quick experiment to show you, which is, here is a 2,000 milliliter Erlenmeyer flask. And if I compare this, and this, by the way, is another Erlenmeyer flask. It's got some water in it. And this one has, let's see, 300 milliliters. So if I find my 300 milliliters here and pour this in here, did you hear the pitch change even as I was tapping? You could hear it getting lower. Now I could compare these two because now they have exactly the same amount of water, just like we did with the other glasses, or we did with the Erlenmeyer, and we changed the flask. But this is changing the size. So here is 300 milliliters. Here is 300 milliliters. Now, what's interesting is it almost seems like this pitch is lower, but that's because of the shape of the bottle. If I hit lower, I can get it to go lower. And watch this again. So let's take my big 400 milliliters and let's hear the change as I change the volume of water in here. What do you think should happen to the pitch? Is it going to get higher or is it going to get lower as I add water? So let's see. I think it's definitely getting lower. Let's try a little more. And it's definitely lower. In fact, let's pour this one because that's only 100. So I get the same result. The more water I have, the lower the pitch. In this case, I only used one pitcher, one beaker, one Erlenmeyer flask to be appropriate, but I changed the volume of water. I struck it at the same hardness level, I hit it at the same spot, and as this volume increased, as this distance decreased, my pitch got lower. So I can prove this law of harmonics with multiple different tests, from Erlenmeyer flasks to two different types of flasks to all the same but change the volume of water to different containers and wine glasses. And all of this goes to show that in the scientific method, if you can repeat it again and again and again, you get to something called a scientific theory or law. Now science, we don't really like to use the word scientific law. Now we still say the law of gravity, but we don't really like that because we know that over time we know more and more things. There's so much information available to us that say Newton didn't know. Newton had to rely on books and what he knew. He really created his stuff on the shoulders of everyone who came before him. The same as scientists do today. It's just that information is shared so fast now. It doesn't take decades to get that information out. It can take seconds. The second that article is published in a scientific magazine, someone else can be taking their methodology and trying to repeat it, just like I repeated this test that's been going on for a long time, and we always get the same results. And if they get the same results, then it's peer reviewed. Peer reviewed by someone else who has good credentials that can perform the same thing and get the same outcome to verify that what their findings were correct makes it good science. Just taking a study that says, I've said it before, bacon is the best thing in the world for you. Well, a study can say that. It doesn't mean it is. If you're a vegetarian, it's really not going to be the best thing in the world for you. And to be honest, if you're not a vegetarian, not getting into that. But you have to be careful of your studies. They can come out and say one day that you can have not enough coffee. The next day you say you shouldn't be drinking any coffee. The next day you shouldn't be, all of this goes on. And you always want to check the source. Has it been peer reviewed? Has it really gone through the method where people have checked it out to make sure their evidence is right? And that's why we have to be good consumers. In 8th grade last year, I did a question on my geology test when we were talking about age of the earth. And I told them, I said, you can Google the answer. I said, how long ago and have we had volcanoes in Minnesota? Well, the problem was they all Googled it and they all got the same answer, but it was the wrong answer. And they all said, because this one person had a Prezi out there, so in this box that looked really official through Google, it said we had volcanoes in Minnesota 14 million years ago, 54 people died, and I think it was something like $1.2 billion in damages. Well, they didn't stop to think about it, because that's why we're going through this, to really talk about that you have to be good consumers of information to know if that information is right. So I had to stop the test and I had to take that question and really modify it because people weren't checking their source. If they had more science background to know that humans have been around for 100, 200,000 years, modern humans, you probably would have stopped to think, hey, wait a minute, 14 million years ago, if there weren't really humans around, how could 54 of us die? And how would there have been a money system to cause $1.4 billion or $2 billion in damage? By the way, the real answer is about 1.2 billion years ago. Duluth and that area down through Taylor's Falls is all volcanic. So there you go for the answer. But it just goes to show you, you have to be careful of who is providing the evidence and double checking your sources. Peer reviewed science, going through the scientific method, helps. Not checking your work, it could be a fluke. That's why when we do experiments, we want to do multiple trials, and we want to have good evidence. So here's a scientific method with harmonics. Yes, obviously a lot of those terms went through very fast, and there's many times you're going to see it again. This was just one. Make sure you understand independent and dependent, what you manipulate and what is responding. What am I controlling? What am I expecting the outcome to be? In this case, remember, my responding variable was the tone. What I manipulated was the amount of water, and that did change the tone. If you've got questions, as always, jump on Zoom, talk to me in class, email. Have a good day.